Woo. Hello, hello, hello. Hello. We'll wait a couple minutes here. It's just people getting rolling. Feel free to chat with me. Say hi. Don't be shy. Oh. Hi, Clara. How are you? What'd you have for breakfast? Lots of highs. Toast. Crazy. Super creative. Hey, Chris. What'd you have for breakfast, Chris? Nothing. Doing the morning fast. Just homework. Homework for breakfast. Just woke up. Nice. Yeah, I'm never super hungry right when I wake up either. It's not. What does it say, Clara, when you try to click on that link? Hello, Alexa. Eunice, hello. Christiana, nice, hello. It's been loading for 10 minutes. That's odd. Maybe refresh it or something, because there's definitely a few of you that are on the whiteboards. If you're not, try to get there. Mine, I have to refresh every once in a while. Kathleen, hello. We'll give it a couple more minutes. And we're going to learn about distributive property. It's kind of a cool idea, I think. Somebody else tell me something cool in the chat. What did you have for breakfast? What did you do on the weekend? Oh, Claire, yeah, just try to refresh it one more time and it should be fine. It says that occasionally for mine too. It just, if you refresh, I think it should pop up. I see both of you in it. Hey, Ashlyn. Cinnamon buns. Okay, that's my goal for the week, Bree. My sister sent me a cinnamon bun recipe. But the problem is I can't find yeast anywhere in the city. Awesome. Yeah, we're going to get rolling here in about 2 minutes. Oh, yeah. See, it is saying bad gateway for me. Maybe it's just struggling a little bit. If it does say that, just refresh and it should go back. Cookies all day. Now you got to eat them. That's the best part. All right. Oh, it's not loading. Well, if the whiteboards are being a little bit tricky, then at least you can follow along on a piece of paper. The nice part about the whiteboards is that when I watch you guys, I can see kind of where the mistakes are happening or if things are going well or not. So that's kind of why I appreciate that. But if it's not loading, try refresh. And today seems to be a little bit weird with that program. Maybe more teachers are starting to use it, so it's kind of overloaded. I'm not sure. Okay, shall we rock? Let's rock. I'm going to talk to you about something called distributive property. And if you're in my classes, you know, for some reason I like to write in caps locks or capital letters, but I don't know why. So distributive property is a little bit of something that maybe we would know without knowing it. There's going to be a little bit of a switch when it comes to algebra in the way that we use it when we have something that is a variable. It's a trick or a tip to solve algebraic questions when we have a letter in our math, like we do when we have algebra. So let me show you the basic concept, and I'll kind of break it down, and we're going to do this in 3 steps. One, without any variables or any unknowns, then we'll throw in some variables and just have expressions, and then we'll actually solve some questions. All right. So right now, this first little section, don't worry about doing anything on your whiteboard, but I will give one example for you, and then I'll get you to try one so I can see what's happening. Okay. So let me give you an example here. 5. Somebody in the chat type a number 1 to 10. Anybody? Type in a number. This is like very interactive. Don't be shy. Hey, thanks. 6. I need another one. 7. Thank you. And Brady, you got that's good for now. I'll use yours later. Okay. So if I ask you this question, what does this equal? Well, here is probably what you are going to do. You're going to say, in order for me to solve this, I have to use something called BEDMAS, and I have to start with the brackets, and I would solve what's in the brackets first. So then I go, okay, what's 6 plus 7? And you would answer with, somebody throw that in the chat. 6 plus 7 is 13. Okay. Now, I would still have to solve the 5. And remember, when we have numbers that are squished or just squished beside each other, we multiply. So 5 times 13, well, 5 times 10 is 50, and 5 times 3 is 15. So 5 times 13 would equal 65. Okay, so that would just be a question that you would solve if I asked you just this top question. Now, I'm going to show you another way to solve this that will actually kind of allude to what's happening with distributive property. So we can solve what's in the brackets first and then multiply what's on the outside, or we can use something called distributive property. So if I am going to switch into red and solve it with my red marker, the same problem, 5, 6 plus 7 is equal to something. What we can do is we know that we're multiplying the 5 by what's inside of the brackets. And when we knew what was inside of the brackets, we could solve that to make things a little bit simpler. But what we could have also done is said, okay, if we need to multiply 5 to everything in the bracket, and it helps when I draw arrows, but if I draw an arrow from the 5 to every number inside the bracket, I'm distributing my 5 into the numbers inside of the bracket. So distributive property means that this 5 needs to be multiplied to the 6 and to the 7. So I could rewrite this as, well, 5 times 6 is 30 plus, because we take the operation that is in between these two numbers, 5 times 7, which is 35. Lo and behold, 30 plus 35 gives you 65. What do you notice about these two numbers? Well, they're the same. So I've just solved this particular question in two different ways. And the focus of today is going to be this way, which is the distributive property. We are distributing the 5 to both of the numbers. All right. So what I want you to try is follow along with me on the whiteboards for this next question. And throw out some numbers here. I see from before 2 and 8 and 5. Let's go. We'll keep it simple here. So 2, start with blue. 8 plus 4 equals. Okay. So first, I'm just going to walk you through how to do this when we are using BEDMAS, and then on your whiteboards, I want you to try using distributive property to solve it. So remember, with BEDMAS, we say, hey, we know what's in the brackets. I'm going to solve what's in the brackets. So it would be 2, and in brackets, 8 plus 4 is 12. Then we could multiply 2 by 12, and we're going to get 24. So you know that your answer is going to be 24. On your whiteboards, try to first write this equation out. And if you can, show me distributive property where you're multiplying the 2 by everything in the brackets and see if you can come up with an answer. I'll give you a little bit of time here to do that. Awesome. Good. So we first multiply the 2 to the 8, which is 2 times 8, and that is 16. And then we multiply the 2 by the 4, and we're just going to say this addition sign is you're adding 4. So 2 times a positive 4. Ooh, thanks. Markers are fading a little bit. I got lots of markers. 2 times 4 is 8. So 16 plus 8 is that 24. Okay, a lot of you on your whiteboards are doing great things. Let me see if I can pull out a mistake that we can talk about. No, a lot of you are doing it great here. See See some good things. Okay, let me grab a fresh marker and I'm going to write down another question, and I want you to use distributive property to solve it. Let me grab a black, it might be better. Here we go. Okay, so 4 and 3 minus 1. So here we've now switched from a addition statement inside the brackets to subtraction, which all that is going to change is you're going to multiply the 4 by the 3, and then multiply the 4 by the 1, and then you're going to subtract those two numbers. Okay, so see if you can figure out what you're going to do here on your whiteboards. Some of you have started writing the equation, or maybe some of you are doing it on pencil. Love it. Good. Thanks, Bree. I know it was a big sneeze. Got her out. Sun's catching me from the side here, so I'm getting him out. Awesome. I love that. Okay, so once again, 4 times 3 is 12, and 4 times 1 is 4, or you can think about it as 4 times -1, which is -4, so 12 minus 4 is equal to 8. All right, now if you solve this first, when you did know, like we have all of the numbers inside, 3 minus 1 is 2, 4 times 2 is 8, so you'd get the same thing. Now the reason that we have to learn about this distributive property technique is that when we are in algebra and we don't know all of the numbers inside of the brackets, we can't just solve what's in the brackets first. So let's move on now to something that is a little more algebra based. And all I want to do, we're not going to come up with an answer. We're just going to express this. So I'm going to, or simplify is another word that we say in math. So for example, if I have 2 and then a bracket, and then it says x plus 4, okay? Now there's no equal sign. This is just an expression, but we want to simplify it. So what would we do here? If I said solve this, most of you would go, okay, I want to think about bed mass, but then we run into a problem because, well, I don't know what x is. So how can I add numbers together when I don't even know what they mean? Well, that is why we have to kind of think about this distributive property technique to get us to a place where we can solve a question. So to simplify, I have that same idea. Multiply everything on the outside with everything on the inside. So this expression becomes 2x, because 2 times x becomes 2x. And that's the trickiest part about all this. 2 times x is 2x. 2 times positive 4, 2 times 4 is 8. So I could express this as 2x plus 8. And that's going to be a really important step, because what do you see here? All of a sudden you see something that's working towards those two-step equations. So if I made this equal to something, you could then solve it. Okay, but this step is what we're concerned about next, being able to go from an expression and then simplify it. So I'm going to write down 2 examples that I want you to try on your whiteboard, and you're not going to solve them, you're just going to simplify them. All right, so the first one, I'll do one on the left side of the board here, so number 1 and number 2. Okay, so we have 3x plus 4, and for the second one on your whiteboard, is going to be 4x minus 2. Okay, so those are two equations. One we have an addition statement, and one we have a subtraction statement. So see if you can work through those on your whiteboard, and I'm just going to kind of watch them as we go here. Awesome. Yeah, and some of you are just going straight to an answer here. That's okay too. If you don't have room to rewrite the question at this point, that's all right. Remember that this needs to be multiplied together. So even in this question, the 4 is being multiplied by 2. And this 3 is being multiplied by the 4. Okay, some of you are just doing the first step. So like, for example, you'd have an answer of 3x plus 4 here. It needs to be 3x plus what's 3 times 4. Yeah, so, oh, where's my marker? So here is, I'm so happy that some of you are doing this because this is a really common misunderstanding. What's happening is we're multiplying the 3 by the x, but we're forgetting to do the same thing. So lots of you here have an answer of 3x plus 4. Okay, so 3x plus 4 is a popular answer. Now, what we need to do is to make sure that we multiply the 3 by the 4 as well. So our answer is not going to be 3x plus 4. It's going to be 3x plus 12. So how did I get the 12? Multiply that 3 by the 4. You need to distribute your 3 into both of the numbers or expressions inside the bracket. And then over here, we're doing the same thing. So we have 4 times x. Once again, you don't have to draw those little arrows, but it helps me remember that I'm taking care of the 4 times x, which gives me 4x. And then I'm going to multiply the 4 by a -2, or I know that's subtracting. So 4 times -2 is -8. Some of you have this, 4x minus 2. Okay, once again, the issue here is that we didn't multiply the 4 by everything. We forgot to multiply it by the 2. So 4x minus 2 is the biggest mistake there. Nice. Good. Okay, now I'm gonna, of course, it wouldn't be right if I didn't throw you kind of a curveball with some negatives. If you can solve, simplify these questions, and I'm going to try to chuck different positives and negatives at you, then you got a real good understanding. So those ones were really good, just the basic form, and that's kind of step 1. If you can get a grasp on these, that's excellent. So let's try to trick you a little bit. So I'll put down 2 more questions. What if we do this? A -4, and we have x minus x minus 2. Okay, it's going to be the first one. Second one will be 3 times negative x plus 6. Okay, there are 2 more I want you to try, and just take your time to make sure you're multiplying and you're thinking about your integer rules, right? Positive, and I can write those down here. Positive times a positive equals a positive. Negative times a negative equals a positive. Okay, there's a little chart to help you remember. Those are rules that you learned earlier on this year. Nice. Catching a couple of you on some integer stuff, but we'll talk about it later. It's so tricky when you get these little negatives and subtractions. If you're sitting there waiting, you can always create your own. You can create your own that's more challenging or less challenging, whatever you'd like. You can do that on a little piece of paper or something. Good. Okay, let's talk about these two. And I'm seeing a couple different things. There's actually probably make an argument for 2 correct answers, which is an interesting thing, but we'll talk about that. So over here, we're multiplying everything on the outside of the bracket with everything on the inside of the bracket. Okay, distribute it. So we have first -4 times x. A negative times a positive becomes a negative, so we get -4x to start, which most of you are getting to this point, -4x. Now, we have 2 different things here. One, we understand that we're multiplying -4 times 2, so some of you have written it like this. -4x minus a -8, that works. Subtracting a negative is the same as saying what? We can say that this negative sign is kind of attacked. We can write this as plus a -2, same thing, which means it's a negative times a negative. So we could rewrite this or simplify this even easier as -4x plus 8. Why? Because when we're subtracting a negative, it's the same as adding. So it's like that double negative, which is a little bit odd, but one of these 2 is good. Either one, whatever way works for you. Typically, when we get to this point, it's a little bit simpler, less negative signs to worry about, but both of these are correct. Okay. Let's look at this one. We have 3 times negative x. So a couple things that I'm seeing. One, 3 negative x. Now, if you look at this, it looks like you're saying 3 minus x. So although it kind of seems like it should be that way, what they do in math is, hey, Paige, good to see ya. What they do in math is they take this subtraction sign and they always put it out front. So they wouldn't write it as 3 negative x. They would write it as negative 3x, okay, which most of you actually caught on to already. So that's great, okay? So once again, that little negative sign goes all the way to the start. So this whole expression is going to be negative. Then that takes care of this. Now I just have 3 times 6. So we get negative 3x plus, well, 3, 6, 9, 12, 15, 18 would be an answer. So negative 3x plus 18, and then one of these two for the first two questions. All right? Nice. That looks great. So you guys are doing really well with that multiplication piece. The only thing is that the positives and negatives that kind of sneak in there, okay? All right, 2 final questions to wrap up this section. And then tomorrow we're going to do this exact same thing, but instead of just expressing them, we're actually going to now solve it. So they're going to be equal to something. And we'll look at how we use what we know about 1- and 2-step problems and now like add this next step, okay? So these are the last 2 questions. Let's make them weird, tough. Negative 4 negative x plus 3. And over here, negative 1 negative x minus 2. If you can solve these two, then you got a really good understanding of this idea and a really good understanding of your multiplication and of integers and your integer rules. So it combining things that we've done through this year, which is really nice to see things play out here. So try these two, and once you're done these two, that's your math for today. Let's see what we can come up with here. Oh yeah, some of you guys are killing it. That's great. $10.14. I'm going to go through the answers just because I know time is valuable to you guys. So I'll write down the answers, and if you want to just continue to play on your whiteboards, you have unlimited time. You can email or text if you want another example. Not text, email or write me in some sort of way. But negative 4 times a negative x, a negative times a negative is a positive. So this becomes positive 4x. Negative 4 times 3 is, well, we can write this one of 2 ways. You can say I'm adding a negative 12, or even simplified is 4x. Adding a negative is the same as subtracting, so 4x minus 12. Each of these 2 ways would be acceptable for that. Over here, negative 1 times negative x. So a negative times a negative is a positive. So we have 1x. Negative 1 times a negative 2 is a positive. So positive 2. And we can actually even simplify this because we often, we don't write 1x. We are lazy in math. So we just say 1x is just the same as x. So this in its most simple form is x plus 2. Some of you I see have gone with 1x minus a negative 2. Once again, this is correct, but it's just a little bit simpler if we say, hey, we know that tic-tac method, or we know that if we're subtracting a negative, it's the same as adding. So that would be a solution there. Sarah, enjoy your breakfast. I'm going to be gone by the time you come back. So once again, have a look at these. These are the trickiest versions you will be able to come across. If you can get the negatives, that's fine. That's amazing. Sorry. If you're, at the point when you're just solving the ones that are just all positive, that's a good start. And you can always rewatch this video because I've done essentially every example that you'll see. So a mixture of positive and negative numbers, and so that'll be great. So you can always go back. This video just stays on my YouTube channel, and away you go. Oh, Eunice, no challenge question for today. Hi, Connor. Let me write one down. I'll write one down, Eunice, and I'll email it to you. So if you want a challenge question, let me know. Email me and I'll email you back an algebra challenge question. Okay, guys, have a good day. Enjoy the sunshine. It's a beautiful one out there. Miss y'all. And if you tuned in halfway through, you just go back and rewatch this. I'm out. Bye-bye.